Okay, well, hello everybody who's joining us today. Welcome to today's IEAGHG webinar on our recent study on applying ISO standards to geologic storage and EOR projects. My name is Samantha Neades. I'm Technical Programme Resource Manager at IEAGHG, and I'm very pleased to welcome you to our webinar today. Just a quick disclaimer slide that we show at the beginning of all of our webinars and all of our IEAGHG presentations. So IEAGHG are a technology collaboration programme. We're part of the IEA's Energy Technology Network. We are autonomous from the IEA, and so any views expressed in this webinar do not necessarily reflect those of the IEA. And a quick overview of today's webinar. I'm going to start with a very brief introduction to the IEAGHG programme and then go on to give you a little bit of background and a brief study motivation on today's webinar topic. My co-presenter for today, David Buchmiller, will then delve deeper to give you a more comprehensive overview of the work undertaken by DNV. So IEAGHG was founded under the IEA in 1991, and we are a member-based organisation with strong membership involvement. Our main aim is to provide information on the role that technology can play in reducing greenhouse gas emissions from the use of fossil fuels and biomass, with CCS being our main area of focus. We pride ourselves on providing information that is objective and independent, that is policy relevant but not policy prescriptive, and work that is reviewed by external experts. And the IEAGHG programme is able to do what we do thanks to our valued members. We currently have 36 members from all across the world, made up of countries, companies and organisations. And IEAGHG helps to initiate and develop knowledge sharing and the transfer of information in many different ways through many different pathways, including through external involvement with the initiatives shown on this slide, and also through the programme's main activities. So we have published over 360 technical reports and reviews so far on all aspects of CCUS. Our international expert networks span a wide range of areas and facilitate international collaboration and knowledge sharing. Events such as the Post-Combustion Capture Conference Series and the GHGT Conference Series are popular and always very well attended, with the GHGT Conference Series having established itself as the principal international conference on greenhouse gas mitigation technologies, particularly CCS. And our international CCS summer schools have been running since 2007. And a quick look at some of our upcoming IEAGHG events this year. We've got a Risk Management Network meeting in June. The 15th International Summer School will be held in July. Our Monitoring Network meeting is going to be held in the USA in August. An offshore CO2 storage workshop, which will be the 6th in the series, will be held in September. And then the 7th Post-Combustion Capture Conference will be held in late September. And for more information on these and any other of our activities, please visit our website at IEAGHG.org. And a quick note on the webinar procedures for today. As attendees, your mics will stay muted throughout. If you do have a question for our speaker, please type the question into the questions tab in your control panel, so you can see that indicated there by that red arrow. We do have the time at the end of the webinar today to take some questions from the audience. So as we're drawing to a close of the presentation, feel free to type any questions you might have in that little box. I'll try and get through as many as I can at the end of the session. And just to note that this webinar is being recorded and it will be made available on our YouTube channel shortly after the event. So now on to the background and motivation for this study on applying ISO standards to geologic storage and EOR projects. So there are two ISO standards specifically relating to the geological storage of CO2. ISO 27914, published in 2017, and titled Carbon Dioxide Capture, Transportation and Geological Storage, on geological storage, and then also ISO 27916 from 2019 on CO2 capture, transportation and geological storage, on carbon dioxide storage using enhanced oil recovery, or CO2 EOR. These standards provide a sound basis for demonstrating and/or quantifying that CO2 is safely stored long-term within geological strata, including hydrocarbon reservoirs, where a CO2 stream is not being injected for the purpose of hydrocarbon production and for storage in association with CO2 EOR. And just to note that IEAGHG are part of ISO TC 265, which is the technical committee under ISO on CCS. We are a liaison organisation of this committee, and we're also part of Working Group 3 on storage, who led the efforts on 27914. And the aim of this report from IEAGHG, the aim is set by IEAGHG and our executive committee. The aim was to summarise, compare and contrast those two ISO standards relating to the geological storage of CO2 and compare and contrast them with regulatory frameworks to provide a high-level understanding of the standards. To achieve this, the contractors undertook a detailed analysis and synthesis of both standards and then compared the two standards to each other, then compared the standards with existing regulations for CO2 storage and CO2 EOR. The study then investigated the applicability of both standards in supporting existing regulations. It then looks at case studies and the application of the ISO standards in real-life CCS projects. And finally, the report evaluates the potential for using the standards to assist in the implementation of CCS projects in areas without specific or tailored CCS regulations. And the contractors for this work were DNV in Norway, and we'd like to very much thank the authors of the report. And as I mentioned earlier, the study is referred to also as IEAGHG report number 2022-11, and it was published in September last year, which means that the work now is available to the general public and can be downloaded from the IEAGHG website. So, and now on to the main part of today's webinar. So I'm very pleased to welcome David from DNV to this webinar. David is a principal engineer at DNV, where he has a wealth of experience on well integrity, especially with well abandonment and CO2 storage. He's worked on numerous CCS projects globally, has a background in risk assessment in drilling and wells, decommissioning and development of projects, and also the qualification of new technology throughout his 16 years of experience in the industry. So without further ado, I'm going to pass over to David, who's going to take you through this more comprehensive overview of the IEAGHG report.
Okay, thanks, Sam. I'll just get set here. So thanks for the introduction, and thanks for the good background to the presentation today. So like you said, I'll give a brief introduction to myself. I mean, that's pretty much given. Have a good background and a good basis for this, and then walk a little bit through who DNV are, who we are, and then get into the main topic, the technical report, and how we have worked through this and the different approach and then findings. So first, a small background of DNV and where we come from. We're a large global assurance and risk management company, present through many locations around the world, with covering many different technical domains, from the maritime industry to energy sector, health and safety, and now also more and more to digital space. So we typically are a third party. We come in with roles within certification, verification, and then also solve technical challenges. We qualify and assure problems and do different subtasks like risk assessment and assist projects to ensure their quality. So with new digital solutions, this has kind of really widened the broad spectrum. More specifically within the topic of today, you know, CCS, carbon capture and storage, and CO2 storage. These three domains, DNV has a large footprint and a large experience over the last decade plus. Looking at the capture side, most of our focus has been on implementing new technology and proving it's ready for use in the capture side, upscaling that from a technical and economical perspective. So helping capture side and bringing those products on the market. In the middle bulk, the transport, that's really kind of the backbone of DNV, where You have ship transport and pipelines, a lot of technical know-how. As we speak, there's many joint industry project JIPs that are being run where we look at requalification of infrastructure, be that for CO2, hydrogen, ammonia, or other kind of repurposing. I think CO2 reuse is one of the main focuses of that. Can also come into some material studies. And then kind of circling back to the focus of today, the CO2 storage, where I work mostly, and where this topic focuses on, looking at applications for depleted in oil and gas reservoirs or saline aquifers, or also alternatively on EOR, where we function as a kind of a third party or a technical advisor and can assist in risk and stakeholder management. One more slide upon that. We have myself kind of pictured in the image on the lower left, looking at wells and well integrity, but we also have a kind of a larger CCS team that covers the whole span, but also on the subsurface, and have more domain knowledge in that regard. So we're able to apply that in our third-party application to the storage project. Similarly, we have the technical insurance, but one thing that's quite interesting is the test sites and labs. CO2 risk man was demonstrated and performed in the UK in Spade Adam, and then just today, I think we had at least an internal opening of a brand new lab in Groningen in the Netherlands. So that's happening now with DNV focusing even more on the energy transition and having test facilities available for that, as well as Columbus in North America and other sites throughout the globe. So that's a little bit of background. I'll now move into this technical report, what this technical report has for content, and how we've performed the study first with an intro, the method that we've used, and then move into findings and conclusions from there. So the objective is, when we have new project development, be that within CO2 storage or CO2 EOR projects, we wanted to map and understand the applicability of these international standards and how they work together with regulatory bodies. The ISO standards are available. They've been available for a number of years, and there's also other good international guidelines available. Many technical papers have been written, operator case studies, and a lot of good work that's able to be used in combination with this. And we tried to bring that forward together as part of this report, which is described therein. More on the introduction, the report does compare and summarize the two main ISO standards, shows their differences in applicability towards regulatory frameworks that do exist, show how this works in case studies, and then apply it for both cases with and without pre-existing regulatory regimes for CO2 storage and EOR projects. Some kind of a background and you could say perspective on this is this report focuses mostly on the blue bottom of this triangle or pyramid, where we look at international standards, the ISOs, and with also a flavor of RPs. But then it has, there's an intrinsic kind of link to the project-specific guidelines or operator specifications, and also to the national regulations. So we do touch into those, but focus on the blue element in the bottom. And by that we mean the ISO 27914, focusing on geological storage of CO2, and the ISO 27916, where we focus on carbon dioxide storage using enhanced oil recovery, EOR. A similar standard that is available or recommended practice, the RPJ 203, geological storage of carbon dioxide, is mentioned as an alternative and compared in a number of these kind of sub cases we look at. A little bit repeating here, but just kind of saying how we've the four main subtopics of this presentation go into comparing and contrasting the standards and recommended practices. Then the second of which being how the standards supplement existing regulations. And thirdly, how the case studies apply to real projects. And then looking at how this methodology can be used in locations without existing CO2 storage regulations in place. So now walking through those 4 topics in more detail with some technical discussion and findings. First of which, looking at the standards themselves, ISO 27914, 27916. On a higher level, they are complementary and be used each of them for themselves. So we see that the 27914 obviously applies for CO2 storage projects and 27916 for CO2 EOR projects. The purpose being for 27914 on the left with commercial, safe, long-term containment of CO2 in storage sites. And then alternatively, 27916 focuses on EOR operations. And then assuming that this, or helping promote this for long-term containment and also quantifying and documenting CO2 storage for EOR projects. I know there's also more work coming forward in the technical group 265 and looking at how this can be promoted, and also, for example, I think the upcoming work is talking about transitioning from EOR to storage. So there is more work in the industry covering this topic at the same time. What we did as part of the report is to align and understand the applicability and the overlap within the standards covering technical topics first. So this table on a high level maps out the applicability. Green you'll see is kind of full applicability, yellow being partial applicability, and red showing not addressed. So firstly, covering the management systems. Here we reference the different clauses also within the standards. So ISO 27914 has, you could say, full applicability for management systems and describes that, whereas 27916 has partial, covering more operations and management plan, and kind of some of the documentation records keeping. On risk management, there's more of an alignment between 27914 and the DNV RP, but lesser, say, discussion and full technical guidance provided in the 27916. Well, infrastructure, 27914 provides kind of a detailed list of considerations that should be part of project development, as does the DNV RP. But then 27916 goes on the high level, providing limited guidance. Operations, you see fuller alignment between 27914 and then higher level guidance on 27916, and then monitoring is more aligned between 27914 and the RP versus 27916. The second of these slides covers kind of site closure and project termination. So what technical aspects are part of that? We see all 3 having good alignment there. Quantification of greenhouse gas emissions. This is a stronger technical guidance is provided in 27916. So that is one of the purposes. So we have an alignment more there in 27916. Permitting is covered in a little bit of a flavor of 27914, but not a formalized process. So that's, say, more applicable in the DNV RP and the way that's described there. Stakeholder management, more on 27914 and the DNV RP. Environmental impact is lesser discussed in the ISO standards and more on the DNV RP. And then CO2 composition and how this may play a role in the project. That's also covered similarly within the ISO 27914 and the DNV RP J203. And then post-closure termination and how that's done. Also, I think specifically on monitoring and management framework is covered less in the ISO standards. So we have this and provide some general background for that. Working forward, kind of taking this to the next step, we looked first at kind of comparing 27914 with existing regulation for CO2 storage. So kind of one of the prefaces or the disclaimer within the ISO 27914 is that it does not intend to supersede any national or international regulations. So it is an ISO standard, not national international regulations. So, but it is comparable in many respects to, for example, the EU CCS directive, the US Class 6 rules, the Australian Offshore GHG Storage Act and regulations. And we describe topics with overlap and kind of alignment within those regulations and ISO 27914, for example, on site screening, risk management, operations, monitoring, and verification. So We see a good degree of alignment. It depends on the technical depth you're looking for on some of the topics, but there is an alignment within the, say, national regulations and allows for a feasible application of cases for places where the regulations exist. Similarly, for the 27914, a comparison was made to the US Class 2 rules for EOR projects. Some of the similarities between the US Class 2 rules and the ISO 2716 are within EOR complex characterization, containment assurance, monitoring, well construction, and well intervention, and project termination. So there's some overlap. Generally, we see that the US Class 2 rules are more dictating, more prescriptive, detailing what should be done on a prescriptive manner. So it does kind of provide more of a different approach using 27916, but it's good to have this overlap on the technical topics. Then a little bit more into the formalities, or not formalities, but kind of applicability for using these two ISO standards when supplementing existing regulations. So first could be site permitting, whether you're early phase in the project, exploration or evaluation permit, a storage permit, an ejection permit, or a closure certificate. So the ISO 27914 has been used for that, and alternatively DNV RP can be used. So that is applicable in that regard. So that's where it has the technical basis to do that kind of permitting and can be used. This can be kind of spelled out. For example, here's an example we've provided, typically aligning towards kind of oil and gas regulations, where you have the CO2 storage license equivalents shown in blue at the bottom versus a typical oil and gas project in the green above. So for the Norwegian regulations, we follow the same framework and process, where the, for example, for a storage plan and development of operation for CO2, you can use that technical guidance provided in ISO 27914 and develop that together with the in a similar way that you would an oil and gas plan for development type approach. So this aligns with the general framework, for example, in Norway, and we've seen in other jurisdictions, so that this provides technical guidance in addition to those regulations, similar to the pyramid I showed in the introduction. Some more application of 27916 for regulations. So this can be and has a lot of usefulness within emissions accounting. Clause 8 is, say, you could say, establish methods, establish calculation principles for quantifying mass of CO2 stored and lost for CO2 EOR operations. So the focus being on the left in the ISO 27916 for quantification of net stored CO2. On the EU, we have quantification of emitted CO2. And then, for example, of California and Alberta, they focus on net greenhouse gas emission reduction. So if we compare back to the ISO, the EU monitoring and reporting guidelines are not fully aligned about quantification of stored CO2. We have a somewhat alignment between California and Alberta regulations for quantification of stored CO2. What we see is a good alignment overall throughout these 4 approaches in CO2 lost, so that this is documented and controlled through the calculations and emissions accounting for those 4 different methods together. Okay. The 3 different case studies we walked out to kind of apply this to real projects, looking at real projects, how have these standards been used, we're looking at some technical basis, and you know, how can they be used in real life project development historically. And this work was done a few years back, so there's a lot more projects on CCS luckily coming forward, and more case studies come forward every day, so we recognize that and look to learn from everyone on that and kind of continue the industry dialogue. Here, so the first goes into site feasibility and site permitting. Secondly, is on well requalification and evaluation of wells for CO2 storage sites. And third is development of M&V programs. So for the site feasibility, the two example projects we looked at was Carbonet in offshore Victoria, Australia. That one, the project used throughout its permitting process the DNV RPJ 203 and the DNV Service Specification 0617 as technical guidance. These guidance have been around for over a decade and were able to guide that process when that project went forward. So kind of a risk-based framework was used. But then the alternative to that can be shown in the Greensand project in Denmark, where the ISO 27904 has been used in this process to align. You have technical basis and use the ISO, you could say, technical guidance where there are no shall statements, but the technical guidance has guided this permitting process and allowed it to go forward and given it kind of the technical basis for that as a reference standard. So that's two positive, good historical references for kind of site feasibility and permitting. Second one covers well requalification. So both the ISO 27904 and the DNV RPJ 203, they provide guidance within well requalification. Here we list out a large list of technical topics, everything from well design to material considerations, integrity challenges, and things that should be a part of an evaluation when reusing wells. So here we also kind of went through other research initiatives, joint industry projects, papers, and other work that has been performed, and see that there are a number of qualitative tools that are available on the market and operator case studies that have tried to study this and quantify the use of wells again for CO2 storage. We also see that a lot of the work within the plug and abandonment sphere can be reused to show well integrity and kind of the good collaboration between the subsurface domain and the wells domain. One case study of note was the Kings North from 2011, where the final conclusion was that the wells were not suitable for CO2 injection and storage, and that was didn't go forward. In the meantime, I know that there's the Portos project in the Netherlands has you could say partial well reuse with a lot of recompletion and re-drilling activities. So there's kind of I think from what I've heard, major overhaul with the wells, but kind of a general reuse case. So that kind of covers and slightly covers the last argument on the bottom of this slide, saying we haven't seen a full requalification or a full reuse case, Porthos potentially being a partial reuse case that is now kind of being worked on in the industry. So some further challenges, we see that this is a complicated issue with a lot of uncertainties that can arise, threats, etc. So understanding the uncertainties from historic operations and using that if we're going to requalify the wells. So quantifying and understanding the risk. We have qualitative tools, but proving that the evidence is there. So we have the framework, for example, in DNV RPE 103, J203, or ISO 27914. So the goal of this is to provide principles for showing that the well integrity is withheld throughout the lifetime. You have control of uncertainties and the risk is proven. So we see that this can be done going forward. There are tools and methods available, and as more knowledge is gained, this will continue to assist the industry. The third case study was covering risk-based M&V programs. So here are some of the main guidance. Good. Throughout the RP as we go forward.
Sorry, David, we lost your sound there for the last probably 30 seconds or so. Can you just repeat the last couple of sentences, please?
Okay.
Thank you, sorry.
Okay, I'll redo this slide on the case 3, sorry about that. So for the case study 3, when we do covering the development of risk-based M&V programs, the objective was to look at both the ISO 27914, the RR rules, and DNV J203. So one of the key takeaways here is that the post-closure monitoring, that there's no specific guidance provided for that, whereas if you have ISO 27914, you can have good guidance, especially through the ISO standard on developing M&V programs, and that can be a good basis for project development. We've seen that in our experience and used that one actively also in kind of verification. So it is a good tool with maybe some improvement potential at the post-closure monitoring phase. The last kind of technical topic goes into using ISO standards in locations without regulations. So the basis for this work is a study performed by the Global CCS Initiative about legal and regulatory indicators. This covered 55 countries' legal and regulatory frameworks, covering 29 different criteria, and so we use this as a basis to describe applicability. So the ISO standards in and of themselves, they provide limited support for legal and regulatory elements. So this, normally the legal elements are covered more on the regulations. So this is where some of the gaps may exist on overall how the approval process is done, specifically in different countries. Ownership, the roles of the regulators, their responsibilities, ownership, transporting of CO2, and how to just if there are dispute resolution. When we see greater alignment and greater applicability is on the technical topics, such as defining the CO2 composition, CO2 stream, identifying and counting for CO2 leakage emissions, monitoring the M&V plans, for example, how is that done technically, how does that support regulations, reporting and verification, how to do risk assessments, and public engagement. So there's a good alignment within the technical topics. What we also did was apply this to 4 kind of case studies with existing oil and gas regulations that can be used to piggyback thereupon. So we looked at Angola, Mozambique, Trinidad and Tobago, and also Thailand and Indonesia. And based on this, where we see the oil and gas regulations today, we see that when one can piggyback on those regulations and use the ISO standards for a technical basis to cover the CO2 storage risks. Specifically, you have a good feasible approach and an alternative way of going forward with these projects without maybe waiting for regulatory frameworks to be formalized. So that does kind of, we don't see showstoppers as kind of the main takeaway here. Then a few slides summing up and discussing and conclusions, showing where these technical backgrounds have led us. So first of all, you know, the ISO 27914, 27906, with other industry guidelines, with other industry knowledge, they can support CCS project development. This can go forward. We know it's going forward. We see it's going forward. This is something we're excited about and support. And then this report also provides that same sentiment. It helps within the permitting process. It helps within the planning and process alignment, and can support emissions accounting. In cases where you have existing petroleum license regimes, this can complement, together with the standards, a way to go forward with CO2 storage projects. Some issues that aren't covered are management and long-term liability, and the approval process in detail. Then just kind of circling back to this pyramid or triangle, basically when you have the foundational base of the ISO standards, the industry practice RPs that are available, this can, together with regulations whether they do exist and project-specific operator experience, provide a foundation and a holistic approach for projects. So the ISO standards are available, they're ready to be used, and they do work together well with the rules and regulations, you could say. Then 2 takeaways here for new CO2 storage and EOR projects. They are complementary with minimal overlap. They have different purposes, but solve the different cases as they should. We know that the TC265 work group has clarified different applicabilities, and that's why we have 2 different standards which can be used separately for their different purposes. And they do provide guidance for project development. So we see a lot of similarities within the oil and gas history and learnings that we can reuse and bring forward for these CO2 projects. So that kind of was a little bit of the summary and thinking. So mainly takeaways, we see that this basis really is available in the industry and provides a good kind of framework for going forward. So I want to kind of thank the IEAGHG program for this work. The peer reviews, we had good feedback, a lot of comments as part of this. Also had good dialogue at GHG 16 last fall, so had a good experience there, and also for DNV for the time to work on this and support it through this webinar, and think it's been a valuable exercise so far. So that's good history, and we want to keep learning and keep the dialogue within the industry. So thanks from me.
Wonderful. Thank you very, very much. That was a great overview, very comprehensive overview on a really interesting and informative study. So yeah, I must say I've had quite a few questions that have come in on the question chat, just asking about the recording of this webinar. So we will be uploading this to the YouTube, our YouTube channel, to the IEAGHG YouTube channel, and we will also be putting a link to that channel on the IEAGHG website. So if you are interested in rewatching this webinar, you can visit the IEAGHG website at ieaghg.org. And yes, also we have had some technical questions come in as well, David. So I will go straight on to those. If you haven't yet asked your question, please type it into the question box and in your control panel. But I'll start going through these to you now, David. So the first question is ISO 27914 and 27916 focus strictly on measuring stored CO2, following a view that including quantification of methane and other greenhouse gases would be a distraction. Now, 5 or more years later, financing and regulatory approval for CCS projects are moving strongly towards considering a project's overall effects on greenhouse gas emissions. Has the absence of criteria for greenhouse gas measurement or emissions impeded the adoption of these ISO standards? And when these ISO standards are updated, should normative requirements for greenhouse gas effects be included?
Yeah, so you know, this is less covered in the ISO standards, as you allude to here, and we see that there, for example, in the EU, there's a greater push to cover the methane and include that. So I think this is this kind of maybe forms an opinion rather than a technical answer, but I think this is a topic that has come forward more over the last few years and could be warranted for update within the technical work group of 265 and consideration. So whether that's handled separately or together, I think the work group should decide that in the panel together. So you know, the focus here being on CO2, the project in and of itself, there are many sub-technical parts, and I think that you ask a really good question. So I don't know how the final solution will be, whether that's included or covered separately, but it is valid, and I think should be considered on a project development. So maybe whether that's an addendum or, you know, covered separately. So support the question, and definitely good technical alignment there.
Yeah, great, thank you. And the next question asks, how does the EU taxonomy affect the ISO standard 27916?
So for CO2 and there's that one's the 27916 does provide the methods to quantifying the CO2 that is to be especially released and leaked out from project storage complexes. So that is also, to my knowledge, part of the EU taxonomy. So there's a kind of a technical overlap and applicability between the two of those. Whereas you see maybe on general less of an EOR projects, but I guess you have it in kind of oil and gas regimes. So it's they are complementary. I guess it's kind of the takeaway. So yeah.
Mm-hmm. Yeah, great, thank you. And this questioner asks, do you see the employment of both ISO standards being tied to regulations worldwide?
I think I try to illustrate this in the pyramid, whereas they are reference standards and they have their own, say, use case, which is clearly defined whether you're doing an EOR project or a CO2 storage project. There are advantages, to each one of the and say learning. So even if you're going for a CO2 storage project, it is still worthwhile your reads to go through ISO 27916 or other industry guidelines to get more technical background and inspiration for your project development. So I think likely these will be reference standards and up to the regulatory bodies in and of themselves how prescriptive and how say tied down they will be to the standards. See in the green sand case, we note that there wasn't any shall statements. The project was used ISO 27914 as a guidance. The technical subclauses were used to guide in the permitting process, so that the requirements should be fulfilled, and to my knowledge were fulfilled, but they weren't so, say, stringently prescribed in that regard. So depending on the kind of the background of your location and your regulations, whether that's more of a prescriptive or risk-based regulatory regime is likely a bit more local, I think.
Yeah, okay, interesting, thank you. And what do you think some of the low-hanging fruits are with regards to regulative applications for CCS projects in areas that don't have a lot of CCS experiences, and what kind of might be some more of the difficult challenges that you can foresee?
Yeah, I think for these areas where there are that lesser or no kind of regulatory regimes implemented with and they do have petroleum guidelines available, to use those and apply those and test them out within projects. Maybe have kind of support in verifying and doing quality assurance within the projects to show that the process can be tested out, kind of learning while doing, because we think that this can be. We have a lot of experience, so you don't have to reinvent the whole process here. You can maybe reuse other regulatory regimes. I know that's possible as well to gain learning from other locations. So, I mean, in general, kind of use what is available and shouldn't maybe hamper or kind of become a showstopper in project development. So, whether the end users or the regulators themselves want to formalize this, then try to kind of work this problem together, both the developing the regulations and showing the project maturation.
Yeah, absolutely. Okay, so the next question we've got, I'll just do a couple. I don't want to bombard you with lots and lots of questions. Yeah. So this person asks, do you know of any specific testing pilots that are going on in EOR and storage so far in the across the world? Sorry. So do you know of any specific testing pilots that have used the ISO standards on EOR for their kind of their design and development of their pilot?
Maybe at least in practical testing, the green sand project is testing. This is more technical of an answer, and maybe what I know they're testing their storage complex for their its performance, and they've done this, say, pre-injection with a jackup rig on site with periodic test intervals once a week. That was done, I think, or is being done now in the first half of this year in offshore Denmark, where they're testing that out and testing the injectivity, testing the technical storage parameters, and kind of proving that concept. So that's in-field testing, you could say, where they're working that problem a little bit ahead, and maybe more of a pilot case in that regard. But also they've tested out using the standards, the 27914, specifically as a basis for guiding project development. So I think projects usually will, from our experience, kind of guide either upon the DNV RP suite or the ISO 27914, or both, if you want to kind of cover both bases, so that you kind of get all the technical assurances performed together. So I mean, there are more and more projects upcoming, and that's great. So the applicability is being, I think, tested all the time.
Yeah, great, thank you. And we have had quite a few questions about the DNV standards in particular. So I'm just going to ask this one question very quickly. What is the use of using ISO standards or the DNV standards in Denmark? Have you got any specific examples of when they've been used, the DNV regulations, particularly in Denmark?
So there's more projects coming in on board to come in Denmark, and the Green Sand one being the kind of the first major one, which followed the ISO practice. So the experience is more operator driven, and what their experience is based on. The regulator may have some say in this. So from our perspective, it's not like there's a right or wrong answer, and there's good technical guidance. I mean, ISO standards are available through your local ISO library, and DNV through DNV library as well. So it's not difficult to acquire these and kind of use the basis that's there. And I don't think I don't want to advocate for one or the other. I think that's a lot of good work together, and the work groups do overlap. So there's more projects will show that I don't think there's a major difference here, no.
Yeah, absolutely. And as you said in your presentation, they kind of thought of more of a guide for projects rather than an absolute must. So yeah, that's all I'm going to do for the questions. But I would just say we've had one comment in just regarding the first question I asked you about the consideration of greenhouse gases other than the CO2. ISO does actually have the 14064 standards that do cover comprehensive assessments of projects considering the full range of greenhouse gases. So just in case anybody was interested in that as well, there is another ISO standard on that. And thanks, Bob Van Voorhees, for popping that in the questions. That's really informative. So yes, David, I'm going to let you go now. Thank you ever so much for that really interesting and comprehensive overview of that report, and much appreciated to you and also the rest of the authors at DNV for your hard work on this report. And so as a reminder to everybody watching today, this report is now publicly available. So if you would like to see the whole report, the IEAGHG report as done by DNV, you can contact IEAGHG quoting report number 2022-11. So that's 2022-11. So if you get in touch with IEAGHG, we'll be able to send you a copy of that public report. So David, again, thank you very much. And thank you everybody for joining us on today's webinar. Thank you.